welcome everybody to week 10, the final week of the term. I know for lots of you this is your first term at UNSW, so I hope it's been good. I imagine right now you might be sort of tired and stressed and juggling a lot of assignment deadlines. Who's trying to get in more than one assignment this week? So everyone's got our assignment. Is people juggling other ones too? No? Oh, yes. Okay, some people are lucky. Yeah, a lot of people are. But yeah, you're nearly there. We're nearly finished the term. So, you know, we're all going well, I hope. Let's, and just remember as well, we do have help sessions. If there is anybody here or at home watching that has been too overwhelmed to start the assignment too, just please let us know, come and let us know and we can help you get started. Okay, so far we've had 38% of the students in the course have done my experience. Ideally, we get a lot more than that. Now, last term there was a lecturer that promised to give away his family recipes if 85% or more people filled in the surveys. I don't have any good family recipes, but I would like to encourage you to do it. Maybe if we reach the 85% level of students actually filling in the survey, we can talk about what I can do instead of giving you some recipes. All right. But yeah, I'd encourage you all to please fill it in. All right. And we'll give you time in the labs, I think, this week. Again, we are running revision sessions next week. Keep an eye out on Ed. And this is also a repeat announcement. This week, in the face-to-face labs, you've got a practice exam. So really, I definitely encourage you all to turn up. And if you're usually in an online exam, go and get a ticket to turn up to a face-to-face one for this week. Even if you just go for like 10 or 15 minutes to log in and see what that practice exam environment's like. Also, keep in mind, if you are sitting there for the whole 2 hours, remember that the practice exam and the final exam are really 3-hour exams. So if you're sitting there and at the end of the 2-hour practice exam, you're thinking, I haven't even nearly finished. Well, no, in the actual exam, you'd have an extra hour. So there's enough material in that prac exam for 3 hours. So don't sort of get mixed up about that. All right, I hope everybody knows when the exam is on. And if you haven't already, I think you've got till Wednesday to choose your seating, like choose your time slot for either the morning or the afternoon. Has everybody done this already? Have you all done this? So get in, the earlier you get in, the more likely it is you'll get the time slot you want. Okay? And then you'll get, later in the week, you'll get everything confirmed, or your exact time slot and locations. All right, any question about any of that kind of admin stuff? Okay. No? All right. All right, so last lecture we did some exam details and some revision, and we did a bit of a vote at the end to see what we wanted to do this week, like what revision to focus on. And the kind of 3 winners were string and command line argument revision, some more difficult linked list questions, and some sample like hurdles, extra sample hurdles. Now, is there anything, has anyone got a preference for what we start with? Otherwise, we'll just start with string and command line arguments. All right. Also, a few people mentioned that they were struggling with question 1, actually. Let me jump out of this. Question 1 in Lab 9. So hands up or on the chat, let me know, was anyone struggling with this question? Yeah, I think quite a few people were struggling with this. So I want to go through, when we do our revision on strings and command line arguments, I want to go through the concepts that will allow you to do this question. Because I think it was the string part and the command line argument part that made it difficult. Is that correct? Okay. Because otherwise you're putting it into a linked list, which I think you've done a lot of. So I think it's the string part that might be the part tripping you up. But let's see how we go. All right. What am I doing? Oh, view. Okay, and the code is available as always. There's a link to that. So we're just going to start and spend a very short amount of time and some just really basic string stuff, then talk about like character pointers that we can use to point to strings, talk about basic command line arguments, and then talk a little bit about how we could put that all together to do the first question in week 9 lab. All right, so yeah, here we do hopefully have something you're familiar with, but let's look at it. So I've got S0 and S1, they're both variables. What are their sizes in bytes? What do they look like? What are they storing right now? Well, yeah, S0 is a string, right? So it's an array of characters. We're initializing it using the string quotes. So we're going to get an array with A, B, C, and D. Is there anything else that will be in this array? Yeah, null. The null terminating character. So actually the size of the array is 5 bytes. So we need 5 bytes to store a 4-character string. So hopefully everyone's on top of that kind of thing. The other one, well, I've just asked for 128 bytes. So right now, this is going to have 128 bytes in it. We're going to have indexes from 0 up to 127. And what's in this string at the moment? Or is this even a string? Yeah, do you have a question or? Oh, what's your question?
Isn't variable length array illegal in 1511?
A variable length array is.
S0, it's specified.
Oh, this isn't a variable length array because right here we're initializing it. Because we're initializing it here, the compiler will know exactly how big to make this array.
Right, so without ABCD, it will be a variable.
Without this, if we just had it like this, you know, this wouldn't compile. This wouldn't compile. The compiler would think, I don't know how big to make this array. A variable length array, which we don't want to use in this course, would have like a variable here, like n, and later we can give a value to n. But at compile time, we don't know how big it is. That's what we're not allowed to do. Okay.
How is it different from max?
So the question is about variable length arrays, which are kind of complicated. But max here, we know for a fact, like if we've hash defined max, when we're compiling this code, everybody knows, oh, this is definitely size 128. We need 128 bytes. Here, we're looking at that. We know for sure, well, the compiler knows for sure, I need 5 bytes for this. If I've got some variable size in here, if I say char s to n, and we don't know the value of n, right? So right now, we don't know how big this array is going to be, and either does the compiler. So we're not allowed to do that in this course. But with max, not just because it's in capitals, but because it's defined somewhere, we can do that. And we can do this with nothing in here because we're telling it exactly what to put in there. The compiler can work out the size. Okay? Does that all make sense? So right now, this one here, what's stored inside it? Nothing really. It's just undefined. Whatever was sitting there in memory is in there. So it's just an array of characters with no defined data in there. We could store 127 characters in there and then a null terminator, and that would be a string. We could store less than that characters and a null terminator at the end of that string, yeah, and that would be a string too. So if I ask for the string length, what's the string length of S0? Yeah, 4. So remember, the string length will be the number of characters that you're actually trying to store, that you'd be printing out. That's the string length. And then we always need to have more bytes, one more byte to actually store it. Okay. If I try to do the string length of S1, what would happen? It would probably give me a runtime error because I haven't defined any data in there. So that's not something I should do, right? I'm working with, we don't know what's in there. So it would probably have a runtime error. Or on a different compiler, maybe print out garbage or something, give us garbage answers. Okay. Now, in the assignment, you've probably dealt with this situation a lot. If I wanted to make a copy of S0 and store it in S1, can I do it like this? No. So we've got people shaking their head, which is good. Why not? Yeah, we can't do this with arrays. That's right. So I'm saying one array equals another. We can't do that. We have to copy all the individual elements over. Or what can we do if we're using strings and the string library? How do we copy? So we could just use stir copy. Now, I would do it like this. This is going to copy ABC into this array, ABCD into this array, and we'll have a copy of that string. All right, is everybody happy with that? Okay. All right, what if we had this scenario? This is kind of the scenario you have in week 9 activity 1. What can we do with something like this? S2, which is a char star. Sorry. I know lots of you are probably working on your assignment or other assignments now. That's 100% okay. But just keep it down a little bit. So what can we do with this kind of variable? What is it? Well, yeah, so this is char star. It's a pointer to a character. That's what we can store in there. So if I do something like this, can I do something like this? Okay. Has anyone tried to do something like this in the lab? No. Okay, good. So S2 can store an address. Okay, we've got a pointer to something. What can I typically point to though? What could I do with this variable?
Make it point to the first character of S0.
Yeah, I could say S2 equals the address of S0 at index 0. And that would be making, let me just draw this up. And in fact, what else could I say? If I just actually type in S0, that gives me the address of the start of that array. So if I do something like this, imagine my S0 string is here. I've got A, B, C, D, whatever. Imagine this array is stored at address, some fake address. This pointer is now just pointing to the beginning of this array. Okay? So I can make a pointer point to something that already exists, right? We've done that sort of thing before. What else can I make a pointer point to? So you've seen this kind of thing before. Often you've got something like this. That's a pointer. What do we often do with this? Yeah. So if I've got a pointer, I can point to some data that already exists, like another variable, or I can malloc and create some new memory and point to that. So if I've got this S2, my other alternative is I could malloc something and then store something in there. Now, if I wanted to store a copy of S0 and point to it with S2, a copy, how big would I need to make my malloced string? So let me just clear this up a bit. So I want to malloc, I want S2 to be a chunk of memory that I malloc, so it's on the heap, and then I want to copy this string into it. How big do I malloc this chunk of memory to be? 1, 2, 3, 4, 5. Yep, that's right. In this instance, it'd be 5. But how would I write it in my program in case we had a different size string?
Size of char times string length S0 plus 1.
Yeah, so I'd do size of char. And how many of them do I have? Well, I could do the string length of my string. Now, if I did that, I'd get a chunk of memory of size 4. There wouldn't be enough for the null pointer, the null terminator. So I would do a plus 1. So this would give me a chunk of memory of size 1, 2, 3, 4, 5. Then I could do my string copy. I could say, let's copy S0 into S2, and it's going to copy it into that chunk of memory S2 is pointing to. And we're going to get a copy of this.
We can do it after we malloc it, right?
Pardon?
We can do it after we malloc it, the function.
We have to do this after we malloc it. Okay, so let's just have a quick look at that. So they're the two options you have with this kind of thing. Oops. So here, yeah, I could say S2 equals S0. And now if I print out S2, what am I going to get? So right now, this is what I first sort of said. I'm pointing to an existing string. So S2 is pointing to this string here. Okay. So if I print this out, oops. Okay. If I print this out, I haven't used that variable, but that's okay. It's going to print out A, B, C, D, right? So S2 right now is pointing to my string S0. Is everyone happy with that? Okay. Now, what's going to happen in this case if I say S2 at index 0 equals Z? What do you think it's going to print out?
Z, B, C, D for both.
Yeah, it's going to print out Z, B, C, D for both. Because remember, if I've got a pointer to something, it can modify it. So right now, I'll just draw it up. We've got S0, A, B, C, D, null terminator. And we've got S2, which is an address. It's pointing to this string. So when we go to S2 at index 0, we're changing this original copy of S0 that it's pointing to, right? So we don't have a copy of the string. We're pointing to an existing string. We can update it. Anytime we update the string S2, we're updating S0 as well. Okay, so sometimes this is what we want to do. Sometimes we might not want to do that. We might want to actually make a copy. Okay, so I'll make S3. So with S3, we're going to do a malloc, like we just looked at before, size of char times string length of S0 plus 1. Okay. Then I can copy this over like this. So now what we've got is we've got S2's pointing to S0, but S3, we did a malloc of size 5, we've done our string copy, and now we've got Z, B, C, D in here. Okay, we've got a copy of it. Yep, question?
Just before this, we saw that if S3 is a pointer, then we can just assign the address and not use string copy. But here we are using string copy.
Well, what I'm saying is sometimes you might want to copy, right? You might want to copy so any changes you make don't affect that original string. Yeah.
No. I'm asking like before this, you said that if it is an array, in that case we can string copy. But if it's a pointer, we can just assign. So here S3 is a pointer, so
Well,
how are we able to use string copy function with S3?
if we've done a malloc first. So if we haven't done a malloc first, we're trying to copy a string kind of into a variable that's meant for an address. But also too, when we do a string copy, it tries to go and find an address to copy that string to, and we don't have one. So this isn't going to work because this is not like an array that's sitting there ready to have string copied into it. So what we need to do is we've just got an address. So I've got, sorry, I should fix my drawing. We've got S3, which can store an address. We do a malloc, and maybe that malloc memory is at, say, at address 80. That's now stored in here, and we've got a pointer to that block of memory, and that's where we can copy the string into. Okay.
If we do not malloc, then probably it will assign some piece of memory where the leading characters are not empty. So we cannot use string copy in that case, but once we malloc.
That's right. If we don't malloc this first, it actually doesn't compile or it gives a runtime error. We've got to malloc this chunk of memory so then we can copy a string into it. Because otherwise, all we've got is a chunk of memory where we can store an address. Okay. So now the benefit of having a copy is I could, if I change this now, if I change S2 to, I don't know, question mark, that's only changing S3 now. It's not changing S0 or S2. Let's just check that. So yeah, this is kind of tricky stuff. So let me, my drawings are a bit messy. Let's move this up here a bit more. So yeah, we've got our original string, A, B, C, D. It's just a normal array of characters. We've got data in there. I've got S2. I've said S2, which is just a pointer, point to S0. So now if I print out S2, it's pointing to that string. It's going to print it out. I've got S3, another pointer. This time I've done a malloc. I've copied that string over. I'm pointing to a copy. So when I change this first character to Z via S2, when I said S2 naught equals Z, it changed this original character in S naught. Down here with S3, when I change this character here to a question mark, I'll change it here. Because it's a copy, it's only going to change it in here. It's not going to go and change the original one. So these are the two sorts of things you can do with a pointer. Have it point to something that exists. It's not a copy, it just points to it. Have it do a malloc and have its own copy of data. Yep, question? Oh, so the question here, on line 19, when I've said S2 equals S0, why don't I need the ampersand? So if I've got any array and I just use the name of the array, that gives us the address of where that array starts. So any array, if I just use the name of the array, that gives us the address of it. So anytime I'm passing an array into a function, Just say I've got some function, you know, and I'm passing any array into it. It could be an array of integers or whatever. I pass it like this, and it's actually setting the address of the array in, and that's why we can modify arrays in functions. If I do an array like this is on the stack, we don't malloc it, okay? If I've got something like this, I don't have an array here. I either can point to an array that exists or something that exists, or malloc it and point to something on the heap. Yeah. Okay, so yeah, this is sort of advanced kind of stuff, but it does help to know this when we're trying to do trickier things. All right, let's go on to command line arguments. Let's just do some basic ones, if I can find it. So if I've got something like this, first of all, what are command line arguments? Do we all know what that means? So command line arguments means when we're running our program, I've given this a very long name, unfortunately. I can put in extra data on here to feed into my program, whatever it is. Okay? Now, to be able to use that inside your program, this is when we need to start using this instead of just int main void, right? And I hope we've all seen this before. If I ran my program like this, what would argc have in it? So I've got the program, I'm running the program, I'm then typing hello, then potato, then cat. What would argc be? 4. So argc is how many things I typed in on the command line when I ran the program, including the actual program itself. What would argv have in it? Well, argv is an array of these char stars. So basically, argv's been set up for us already. We don't have to worry about whether we malloc it or we don't malloc it or anything like that. It's all set up. It's going to be basically an array of strings. And in this case, it'd have, you know, the name of the program, basic, I've just written basic, but it would be basic command line args, then hello, then potato, then cat. And this would be an argv. And we can just think of it as an array of strings, and we can go and just use these arguments like an array of integers. We can just go through them one by one. All right? So if I just wanted to print all of these out over here, how would I do it? Yeah, I could just use a for loop. I can just say for int equals 0, I know how big the array is because I've got argc. Okay, and then I can just print out, I know that all of these are strings, so I would just say print %s. If I want a new line, I can print that out. And I would just say, let's go print, this is argv at that particular index. Okay, now if I do that, and I type this in, yeah, it should just print out all of the arguments one by one. Oh, I've got to compile it. Oh, I've compiled it again. Yeah. At index 0, we're printing out basic command line args. Index 1, we've got hello. Index 2, we've got potato. Index 3, we've got cat. Okay? Now, if I didn't want to print out the program name, what would I change?
I equals to 1.
Yeah, I is equal to 1. So often we might not care about the program name and we just want the rest of that sort of input. We would start it at 1. Okay. If I wanted to find the string length of all of these, I could just say string length instead or as well. What have I done wrong here? Oh, let's see. Oh yeah, that's right. If we're printing out the string length, which we don't often need to do, we've got to use LD or LU. Okay, so we can get the string length of all of these things. One more thing before we move on. If I just wanted to get the first character of each of these and print that out, how would I do that? So if I just wanted to print the first character,
dereference RV of, no, RV of I of 0.
yeah, so if I just wanted to go to argv at index I, that's going to give me a whole string. So just imagine I'm at I is equal to 1. That's going to give me the whole string. If I've got a string and I go to index 0, that will give me the first character. So I could do this. I can either treat it as an array of strings, or I can go down to the character level by using a second index. All right.
We can just also, could we dereference it directly?
We could dereference it directly to get that first character. But we can, yeah, I tend to prefer to use the array notation for something like this, but it doesn't really matter. Oh, here I had no command line arguments. Okay, this is a bit ugly. I've got, let me try one more time. All right, we got the first letters out. Now, does anyone have any questions about command line arguments or strings before we move on? Yep, question?
When you say it stores the number of arguments, do you mean like it stores each letter or like the word itself?
It stores, well, it's a string. It's argv is an array of strings, so it'll have the string basic command line args in there. And on the command line, it's separating it by spaces. So then the next string will be hello, the next string will be potato, the next string will be cat.
No, argc would be free in this.
No, argc will be 4 because it includes the name of the program. Yeah, that name of the program is also stored in case we need it. Often we don't, so we start at index 1. Okay? All right. Okay. Now, in the question you had to do, basically, you're given a struct like this. It's got some sort of char star in this node, and then there's a pointer to the next. So you've got a linked list node, and there's a char star in there. And what you're meant to do is go through the command line arguments and put them into a linked list. So what we're meant to do is, let's just compile it. We're supposed to run it like dog, cat, fish, and we're supposed to end up with a linked list that has, oops, head, that has like dog, cat, fish in the linked list. Okay? So we know how to go through the command line arguments now, right? So to go through those command line arguments, we're going to do what we just did. We're going to go from command line argument at index 1. So remember, we've ended up with an array of strings. We're trying to turn that array of strings into a linked list of strings. So I've got my command line args. I've got dog, cat, fish, right? So basically, for every single argument, I want to take arg v at index I. What do I want to do with it? If we're just writing this out like a plan, I want to take each one of these out of, I want to get each arg v at index I, for example. So imagine I've got dog. I want to then create a linked list node with arg v I stored in it as the data. So I'd want to go to this. Let's just get rid of this. Where's my eraser not working? So yeah, I want to create a node, like malloc it to create the node. I then want to set it to somehow be able to point to or store this string from argv. And then I want to connect it to the rest of the list. So I just want to do this one by one. So the first step is I need to create a node with that string from argv in it. Then I want to connect it to a list, to the end of a list. Okay. Now, how do I create a node? So let's just try and think of one thing at a time. Hands up who knows how to write a function to create a linked list node. Yeah? So what would I do? I'd say struct, in this case it's person is the name, it's not node, we're using struct person. I would say something like new node, then what would I do? Malloc, size of, struct person. Now at this stage, I'll get rid of this again. At this stage, all I've done is malloced a chunk of memory and I've called it new node. I've got to set the data inside it. How am I going to do that when I've got char star? So I've been given some name, so this might be dog. I don't know why I've decided to call a person dog, but whatever. I forgot these were names. We're passing in dog for the name. We need to put it inside this node somehow. Yep.
Should we be doing this in like the function below main, or is it fine to do it around?
Oh yeah, it's bad to do it here. I'll move it. Yep, good point. Bad style to have it up here. Yeah, how do I get this name in this node? Well, if I just do a string copy, new node, name, what's going to happen? Oh, like this. Is this going to work? Yeah, this is like exactly kind of what we were doing with just a basic string. This name here, it's just a pointer. This can store an address. So this is just a pointer. It doesn't have any memory allocated to it to store any data for a string. Okay? So we can't just string copy into it. This can either point to a string we already have, or we have to malloc so it points to a chunk of memory. Then we can copy it in. So we have to do one of those two approaches. So I either have to say new node, name equals malloc, size of char times string length of the name we want to put in there plus 1. Okay, once I've done that malloc, so what I'm actually doing here I've made my node, I've mallocked that. I'm now mallocking a chunk of memory to put my string in. Then I'm copying, in this case, dog into it. Okay, so this is my new node. I've asked for a chunk of memory. In that chunk of memory, it's got a pointer. I'm doing a malloc to get a chunk of memory for a string. It can point to that. So this is one approach to how you could do it. Does that make sense? Now, once we've done that, obviously we'd have to set new node, next equals next, etc. So it's this part here that I think makes it kind of more complicated than when we're just using nodes with integers. And it makes it a little bit different to what we've seen in the assignment, because in the assignment, you've been doing stuff like this. If I've got an array like this, let's get rid of that. If I've got an array like this, yeah, I can just string copy straight into it, into the node. Here, this doesn't have memory allocated to it for the string data. You need to malloc it. Or, what's the other thing we could do? I could just make it point to that original name if I wanted to. Typically, it's better to make it a copy unless you really have a good reason for not doing that. So this is how you're going to be able to make your nodes in this question. You need to just do this for every single command line argument in this loop, create that node, then connect it to the end of your list. Now, hopefully, once you've created a node, I mean, you might still be working on linked lists, but you should be able to work out how to connect it to the end of the linked list. But this is how you could create the node. New node. And I'll just copy this down because, yeah, it's bad style. The other question that we've got to face then if we've done this is if I've got a node, so remember if I'm freeing my linked list, I've got to free at the end of the program, I've got to free every single node. When I free this node, I've got the malloc I did for the actual node, and then I've got the malloc I did for the string. So I'd have to free both of those mallocs, right? You need a free for every malloc. So in my free node, if I just said free n, I would end up with a memory leak because I'd done a malloc on the string. So what I would have to do, I can't say free n and then free the field within it because I've already freed n. I have to free the thing that's inside it first. Okay, so if you do it like that, you've got to go free that memory. Okay, so I think this is probably a bit tough for a 1.1 lab question. So if you struggled with it, I completely understand. I hope this has kind of helped and not made it even more confusing. But does anyone have questions about this create node and how we work with this char star? Yep. Question?
Quick question. When you have a pointer, can it only point to an address? Is that anything you can do?
Well, a pointer variable stores an address. So all you can put in it is an address of something. And because we don't know where addresses are, we can't go around hard coding them. We just can't say, okay, this address equals OX, you know, FFAB, blah, blah, blah. So we've got to get the address of a variable that exists in our program, or we've got to do a malloc and ask for more memory and put that address in there. They're basically the two options you've got with a pointer. Yep. It can't store anything else. Once you're pointing to something, you can then treat it like an array and access things with indexes. All right. We're going to have a break. after all that. Clear your heads. When you come back, I'll give you a quick look at the exam environment. Then we'll do some more linked list and array just hurdles. Okay. All right, and let me know if there's anything in particular you want to do. All right, so let's have a break and come back at about 12. Everyone, I'm just giving you a quick look at the exam environment. So you'll be seeing this week when you go to your lab. And this is what you'll be also using in the final exam. So you'll have a chance to play around with this. But as soon as you log in, you're going to have 10 minutes reading time, and you can read through this thing in your actual exam. Then once 10 minutes reading time is over, you're able to start coding. At that point, you'll be thinking, you know, where's my X term, where's VS Code, where's whatever. But you can right click and you get a whole menu. I can ask for this terminal. I can ask for VS Code. It's giving me a welcome. I can choose my color scheme if I like, or I can just leave it if I don't care. And you know, if I do an ls here, all the files, I've already been playing around in here, but you'll have all the .c files ready to go. You don't have to run fetch or copy, it's all there. And you can open up VS Code and they're all there. You can do things like, and it has the instructions, you can do things like, auto test. So if I wanted to auto test prac Q1, I can. Where's my X term gone? You know, I can test that. I can, instead of give, we've got submit, but it's pretty much exactly the same thing. You submit each question, okay, and you auto test them. But yeah, the right mouse button gives you access to this menu here, right? And also, that's right, we can bring up the course website. So here's the course website. It's not connected to the actual internet. It's just a local copy. So anything you can access here, lecture slides, oh gosh, whatever, these cheat sheets, that's all going to be accessible to you during the exam. If you try and go to YouTube though, no, it's not going to let you, or any sort of external things, all right? That's the main thing. I've been through basically these instructions about the exam. You can see here that it's clearly marking where the linked list and array hurdles are. I can jump to individual questions. I can go back to the, you know, information here. Is there anything I need to tell you? Oh yeah, you've got to answer all the questions in C. So you can't decide, actually I know Python and this one would be easier in Python. No, some people have done that in the past, or whatever, it's got to be in C. Any questions about this? Yep.
I noticed that submit command takes the name of the executable as well. Yeah, below that.
Below, where's it gone? Oh, right. Yeah, so just use that format.
So is it like if I do not compile the code before submitting, so...
Oh, that's not the executable, that's just basically the question name.
Oh, okay.
Yeah, you don't, if you haven't compiled it, it should be fine. It's
So it's submit, question name, file name.
Yeah, it's question name, file name, yeah. Okay, and then you've got auto test as normal. Remember, we don't have DCC help. We do have DCC. I've already done this, yours won't say passed when you log in. DCC works, DCC help doesn't, DCC sidekick doesn't, auto test help doesn't. So you'll see all of that this week. Anything else before, yep?
Will these be the other practice questions we have access to?
This is the only whole practice exam you've got access to. Today I've got a bunch of practice questions and I'll have more. We're not going to get through them all today, but I'll add a few more as well for Thursday that you can do in your own time that we don't get through. So they're practice questions. This is the only sort of full exam that's showing you from start to end. Yep.
If we fail, will it show us where we failed? Like how it was in
It'll just be like auto tests. Shh. It'll be like running auto test for a lab or DCC for a lab. You'll get all that information. The only thing you can't do is then say DCC help or auto test help.
But would we also be able to run like the 1511 version of it where it's like all correct?
This is the same thing, it's just in the exam environment. So this will just be the same sort of auto test you do for the labs. It just doesn't have auto test help, and DCC will be the same, it just doesn't have DCC help. Yep.
Could you give all the details about style?
Style, there's no style mark. There's no mark for style. So you're doing style so you can understand what you're doing and you don't confuse yourself. You're also doing okay enough style that if we have to read it because you didn't pass all the tests, the auto marking, if we have to read through and assign a mark to you, we can understand it and see that you've done some good work. So it's just having good enough style that we can understand it and you can. But we don't actually give you marks or take away marks for bad style. We don't need you to document it and have all comments. Just for your own sake, do some indentation, have decent variable names, not X, Y, Z, unless they're the names of some maths equation or something. So you can read it and we can read it. Because, yeah, there's not going to be many, if any, people that pass every single auto test in the whole exam. So everybody at some point is possibly going to have a file that we're going to really have to look through carefully to see how many marks to award you. And if you don't have the indentation there and you've got A, B, C, D, E, F, G as your variable names, it's just going to make it harder, and we might not see that you've done something really, that you could get marks for. So that's the only reason, for your own sanity as well. There's nothing worse than a ticking clock and a bunch of compiler errors and your code isn't actually indented and all the names are bad and you can't remember what you've done. So spend that extra second thinking of a good variable name and doing the indentation. Yep.
So even if the code isn't 100% working tablet in the past level, the examiner may still get marks.
Yeah, there are partial marks given. So basically we're going to pretty much look at all the code anyway. Even the code that passes all the tests we'll have a look at. Just to check, because sometimes also we say you're not allowed to do this or you're not allowed to do that. Or people just hard code answers. So we go and check all these things anyway. But definitely the auto tests are a guide for you to help you do the right thing, but they don't represent the mark you're going to get. Obviously, you're going to feel better if all the auto tests say that you've passed during the exam, but it's not 5 out of 10 auto tests doesn't give you 5 out of 10 for a mark, Yep.
If I pass all the tests, can I assume that I get a full score, or are there hidden auto tests?
The question was, this is a really important question. Can I assume if I passed all the auto tests that I get a full score? There are hidden auto tests. Now, for the earlier questions, if you've passed them all and you've written the code properly, you haven't done anything you've been told you're not allowed to do, that's a good chance, you're going to get full marks. For the later questions, we don't give as many auto tests and you might have to rely on testing it a little bit more. Okay. One thing, I guess I should show you what I mean. Sometimes, maybe I won't do it in the exam environment. Sometimes we might say, and I don't think we're going to say this in this exam, but we might say, write code where the user types in 4 and you print out 4 stars, for example, right? That could be, imagine you've got a question like this, and imagine for your question, imagine in your question, you do something like this, if, let me just do int x equals scan. Right, some people, when they're struggling, they don't know what to do. What they do is they see, oh, in the auto test, there's an auto test where x equals 5. So I'm just going to say if x equals 5, let's print out, right? And in the auto test, they test for x equals 13. So I'm just going to have a case for that. This is what we call hard coding to the test. And sometimes people might even do like 100 different cases like this during the exam. And then as soon as we do run an auto marking with any extra case, it's going to fail because they couldn't have possibly hard coded it for every possible integer value, right? So if you're not doing something like this, for the early questions, it's a good sign if you pass all the auto tests that you're going to pass that question. But I just want to put aside, you just never know what someone might do in an exam where we might not give them like full marks when they pass auto tests. So something like this would possibly get, 0. Okay, because you're not really solving anything. All right, yeah, one more question?
What does passing a question mean?
Passing a question means you're going to get 50% of the marks for that question.
So like passing
No, it doesn't mean 50% of the auto tests. So you can't be 100% sure based on how many auto tests you get right in the exam, whether you've passed that hurdle or not, unfortunately. Okay? And again, the other situation, this is quite an obvious one. I think I talked about this the other day. If you've got a function and you even just do something like that, regardless of what that function is meant to do, you might pass some auto tests, right? And so you might happen to pass 3 out of 10 auto tests or something. That doesn't mean you're going to get 3 marks because we're going to look at this code and you've done nothing. So there are situations, So if you've done an earnest thing, and this is a very obvious one, but you might have the equivalent of it accidentally passing some tests. So it's just not a guarantee, but it's a very good sign if you've earnestly done a solution. If it passed all those tests, that's a very good sign you probably have passed it.
Like you can just return null, and for questions like deleting from an empty list, it will still work.
Yeah, if you just return null, you might pass a few cases from, deleting something as well, So they're not really going to help you. If you've properly answered the question and you're passing everything, that's a great sign. I hope that makes sense. It's not, All right. Actually, let me log out of this exam environment. So definitely, I would advise you to at least try a few of those hurdle questions in the exam environment. Try and do them under exam conditions. So you're really going through all the things you might need to do in an exam. Oh yeah, question up the back.
What would be the distribution of questions? Some questions that we have done in the weekly labs, right? Some of them is just checking for a particular function, and then it's not checking for the main, and then some of them, what would be the distribution of such questions?
Okay, so the question is, sometimes we just get you to write code for a function, sometimes we get you to write a whole program. Oh yeah, there can be a mix of both. I mean, I'll show you some hurdle questions today as well, and you'll see that practice exam. I think typically more will be a function than a whole program. It just depends. So, all right,
Will there also be debugging questions like in the lab? You get debugging?
There will be debugging questions. So in the last lecture, I gave the exact sort of thing of there'll be 4 hurdle questions, like 2 arrays, 2 linked lists. Then there'll be 4 debugging questions that can be on different topics. They could be on strings, pointers, whatever. Then there's a harder array question, a harder linked list question, and then just a super hard question that we say is 4 dots or skeleton level. All right. Let's have a look at some sample hurdle examples. I'm not going to code them all here right now. I'm going to leave some of them for you to try. All right. Now, this is one I'm going to leave for you to try as revision for yourself. But in this case, yeah, you're finding the range, the difference between the biggest term and the smallest term of a linked list. Now, I'll just get rid of all of this stuff. Okay. Revision questions. Okay. So there's a few one-dot questions in here. 2 of them are linked lists and 2 of them are arrays. So yeah, this is the one-dot question I'm leaving for you to try on your own. It's got a lot of text explaining what you need to do, and it gives you a node, and what you have to do is implement this function. Don't forget to get rid of this return that, it's a stub function. And down the bottom, it's got main that you don't really have to worry about. Okay, so I'll leave that one for you, but we'll do one of the one-dot linked list things now. So sometimes for these one-dot linked list questions, you might actually get given 2 linked lists that you have to do something with. And for the one-dot hurdle, you don't usually have to actually, you don't have to actually usually delete something, insert something, anything really tricky. Usually looking through, calculating something, comparing something. But yeah, sometimes you are given 2 linked lists. So in this one, we're given 2 linked lists and we need to return the number of values in the first linked list that are equal to the corresponding values in the second linked list. What does that even mean? Corresponding just means, so if I've got 2 linked lists, and they might not be the same size even. Head 2, head 1. We're just checking. We're trying to check, are these 2 equal? Are these 2 equal? Are these 2 equal? Are these 2 equal? When we say corresponding, we're looking in the same sort of position in both lists and saying, are they equal? So if this was 3 and this was 3, yeah, they're equal. Here we've got 5 and 1, that's not equal. It doesn't matter that there's a 5 over here, it's not in the same corresponding position, right? So this is what we're trying to do. Okay, and we would return 2. Is everyone clear on what we're trying to do in this question? So there's 2. In 2 positions, both of the lists have the same value. Now, how are we going to write something like this? Yeah, so what do we do to solve this kind of question? Any ideas? How would you do this?
You just go through the loop and compare each data, and whenever you find something wrong, you return the wrong number, like x equals to 2 if it's wrong, and then immediately shut down the loop.
Okay, so we're trying to count the number of these matches, but yeah, what you were saying about we loop through it, that's correct. How are we going to loop through it? What do I have to do in order to do this loop? Oh yeah, I've got to make 2. So often we have current equals head or something, but I'm going to need a current, because I need to look through both of them at the same time. I need to have a current that's going through this list. Oops. Current 1 that's going through this list, and current 2 that's going through this list. I need 2 of them at the same time. I can't go through the whole first list and then go through the second list in this example. That's not going to help us. So I would do something like this. Okay, now what's my while loop going to be now that I've got 2 lists that I'm looking through?
Anyone, because the length is same.
Well, we don't know if the lengths are the same, but oops. We can't compare anything if either one of them are null. So they both have to not be null for us to keep going. As soon as one of them is null, we have to stop. We can't find matches. So something like this. And what are we going to do? Well, I've set current 1 to the beginning of this list, current 2 to the beginning of this list. We're basically trying to work out if they're equal. If they're equal, we have to add them on to our total count. So I better have a count or total or something initialized to 0. So how do I check if they're equal? Yeah, what am I going to say? If current 1 data is equal to current 2 data, then we found a match. They're at the same position within the list. That's what they mean when they say the same corresponding position. So now we increment it. Now down here, we've got to move them both along. We've got to say current 1 equals current 1 next. Current 2 equals current 2 next. And then at the end, we need to make sure we get rid of this 42 and return what we want to return in this case. It's just the total number of matches that we found. Okay. Does this look okay? Let's try and compile it. Now if I run it like this, this is checking for an empty list. Typically these list questions, we enter the data on the command line. So this would be checking for an empty list and we're getting 0, that looks good. What about, and here I've got like 2 different lists separated by a dash. This is how we're going to run it. That's what the main's been set up to do. This is saying we've got 3 that are equally the same position. This is going to say we've got nothing equal in the same position. Oh yeah, 2. Oh my goodness. Lucky my program's smarter than me, right? Yeah, what else? Yeah, so it looks like it kind of works. Let's just test this one we're given. What about if it's different sizes? Yeah, it's not crashing. Well, was it giving the right answer? I didn't check. Yeah. So, and these are the sorts of auto tests you'd be given that test things like that. All right, any questions about that one? Yep.
Useless question, but can we use something like total plus equals? Current 1 data equals current 2 data, like using the fact that the boolean is either 0 or 1? Or would that be typecasting, so technically illegal?
If we're using type plus equals.
Instead of the if condition, if you just write total plus equals, and on the RHS we have current 1 data equals current 2 data. So that would be 0 or 1.
Yeah, you could do stuff like that, yeah.
Because that's technically boolean to be
Yeah, if you've got any fancy shortcuts like that that you want to do, that's going to be fine. Yep.
that won't be illegal.
Yep, that won't be illegal. If you're using some function in a library and we say you're not allowed to use string.h and you use that, that's not legal. But just obscure C code like that, I think is fine. Yep. Yep.
Because like if in the really exam I can't understand, but very like exactly understand
Like if you don't understand the question, so this is a very good question. If you read the description of the question and you're not sure what to do, hopefully we give you enough of examples like this where you can see what the input and output is, that even if the words aren't clear to you, the examples should help you. Do you know? There'll be lots of examples. So if we go back to clarify, look, you can put your hand up and clarify and try and clarify something with an invigilator, you can. You can't get them to sit down and explain the whole question to you, but you can say, does this mean this? And they, you know. But typically we're going to have a lot of examples that you'll see, not just words. Yeah. Okay. How are we going for time? We've got time for more. Here's an array hurdle. This is one I'll leave for you to do too. It's a 1 dot. This is quite similar, but it's on arrays. You're given 2 arrays of the same size. This time you're returning the number of items at corresponding indexes that are both odd. You're just checking, is this one odd and this one odd? I'll leave that for you to try. We can do this one here. So array struct capitals. We've got an array of structs of this type, and we're returning the number of structs that don't have capitals for both of their initials. So these are the types of questions where your brain, when you read it, might go, what? So there'll be lots of examples. So I'm going to do this one because this is the trickier one of the two. So we're going to be given some kind of an array of structs. Each struct has a first initial and a last initial. These are both capital letters, right? So we're going to ignore that one. We've got another one. I don't know. These are not both capital letters, right? One of these is not a capital letter. So we're going to count this. This is an example of a struct where it's not both capital letters. Over here, we might have another struct that doesn't even have any letters in it at all. We'd be counting that. They're not both capital letters. Here we've got E, F, whatever. We're not going to count that. They're both capital letters, and so on. Right? We're looking for ones. So there's 3 here that don't have 2 capital letters. Is everyone clear on what we're trying to do? Okay. So how are we going to do it? We've got our array called array, and we know the size of the array. So what's our approach? Basically, we just want to go through every single item in this array, right? How do we do that? How do we just go through? Well, this is an array. Yeah. So for an array to go through from beginning to end, we just do this. This is how we traverse through a whole array. Okay? Whether it's integers, structs, chars, this is just going through every element in an array. Now, for each one, what are we trying to do? And I'm just going to have some kind of counter set to 0. What are we checking for? We're checking if, now in the struct, we need to check the first initial and check if it's an uppercase letter or not. We need to check the last initial to see if it's an uppercase letter or not for each element. So we'd be at array index I, and we somehow need to check the first initial. We somehow need to check the last initial. Now, we're looking for ones that are not uppercase letters, right? How can I work out, what's the logic I use here? Or how do I check if something's an uppercase letter or not an uppercase letter.
Between capital A and capital C.
Yeah, so if I've got something that's greater than A, for example, oh no, I'm looking at uppercase. If I've got something greater than A, and less than or equal to Z, I know that that's uppercase, right? Does everyone agree? If I've got something that's less than capital A, or it's greater than capital Z, what must it be? Not a capital letter. So if it's less than capital A, greater than capital Z, it's not a capital letter. So this is basically saying if the first initial is not a capital letter, or the last initial is not a capital letter, then we want to add it to our total. And then we want to return our total at the end. Okay, so we could do something like this. Does this look correct?
Less than equal.
I've typed something wrong. I can hear someone saying something. Line 14. Ah, yes, first initial, thank you. Okay. Let's try and compile it. Let me get rid of my picture. Three. Now, how do we know if that's right? Let's look down here at the data we've got. We've got one struct with A, capital F. We wouldn't count that. We've got another struct here that doesn't have two capital letters, so we count that. This does, we don't count that. This doesn't, we do count that. This doesn't, we do count that. So we should get 3. Has everyone seen this kind of thing before? This code down here. So you don't have to be able to write code like this. This is just setting up an array of structs. Each struct we're putting the data in like this. Okay, so you don't have to be able to write code like this, but it's setting it up. 1, 2, 3, 4, 5 are in this struct. All right, any questions about that? Now you might want to use C type and use is upper or not is upper or something like that. That's fine. So you can go and try to do this yourself later in your own way, okay, with different logic. Okay. All right. Yeah, we've got time for this. Let's do this linked list duplicate example. So this is basically a 2-dot hurdle. All right, so this is an example of a 2-dot hurdle. In this one, we're given a list, but for every node in the list, we want to duplicate it and add it to that list after it. So what does that mean? I've got this node here. It's got an A in it. I need to make a duplicate or a copy of that node, and I need to add it into this list. I've then got this node B, which was in the original list. I need to make a duplicate of that and I need to add it to the list. So I'm going to end up with a list that's twice as long with a copy of each node after it. Now, how do I go about doing something like this?
That's just insertions, right? And current will move 2 steps instead of 1.
Okay, there's some good like low-level steps, but what we need to think about, even when we just, first of all, like definitely do it on paper or like write it down to see what's going on. But what I just did then, it depends how we do it, but as to what like technical things we need to do, but let's think of a sort of a high level plan. So I need to go through every single node in this list, right? Who agrees? I need to go through every single node in this list to look what's inside it and make a copy of it. So at some point, I'm not needing to have a current that goes through every single thing in the list and starts at the beginning. And I need to keep going till I get to null and there's no more copies to make. For every node in the list, I'm going to create a copy. So I've got to kind of do a create node where I put this data in, like the same data. I've got to do a create node. So we know how to kind of do both of those things, right? Now, when I've created this node, I've created this new node. So imagine I've created it, I've put this data in it, but I need to connect it to the rest of this list. And at this stage, I've got current pointing here. Just think of this step here. How do I connect this node to this list that I've got? I want, basically, it to be connected like this. How do I write that in code? So I need to do this connection here. So this would be new node, then what?
Next is equals to current next, and current next equals new node.
All right, that's right. Let's just go a bit slower. So just new node next, but yeah, exactly what you said. Awesome. New node next equals. So we want the next node after this to be current next. All right. So this is current. This is current here. The one after current next is this one here. We're saying new node next equals current next. We're setting new node to point to the one that's after current. Is everyone happy with that connection? Okay, once we've done that, we don't want current pointing to this node anymore here. We want the one after current to be what? Yeah, the new node, that's right. So this puts this link into here, all right? Which is exactly what you said before. That connects it to the list. Now, any questions so far? I would need to keep going though. Now, if I say current equals current next, I'd be moving current to here, which is not what we want. We would be infinitely making nodes with A if we kept doing that. So what do I say? Current equals what? Yeah, I could say current equals current next next, or current equals new node next. But I want it, I want it to be pointing to here. Okay, and then it can continue and it just does the same thing again and again and again. Okay. Do you want me to code this up or do you want to try and do that later? Some people want to code it. Okay, we'll code it. So let's go, and because yeah, maybe I'll make mistakes. There's a high chance I'll make some mistakes while I'm doing this. which is always good. Okay, so I'll bring back my drawing actually. Maybe I won't. Okay, so the first step is we're going to make current equal to the head, right? So I've got current is equal to the head. And like we've really kind of planned, we're going to go through every single node in this list until we get to the end. At the end, let's get rid of this null now before I forget. We're going to return the head of the list. Just a quick question. Is the head of this list ever going to change if we do our code like this? Never. We're never going to have that situation where we're inserting it as the first node, because we're always duplicating something and sticking it in after it. So that reduces the number of cases we need to think about. Yep. Okay. All right. So for every node, we need to make a copy of that node. And in the exam, no, you don't have to write these comments. I'm just writing it for the sake of us so we can think about what we're doing. So I would say struct node, new node equals malloc, size of struct node. Now, hopefully you've become quick at typing that. All right. What am I putting inside this new node that I've just malloced? So I've got a new node. I'm calling it new node. Yeah, I want to put current data inside it. So I say new node data equals current data. Good. Now I'm connecting it up. I'm connecting this to this. And before we worked out that that was new node next. It's not going to point to current. It's going to point to the one that's after current. So now we've got it connected up, our new node, to the list, sort of. But current is still connected to the wrong thing. So we've got to say current next equals this new node. So these two lines connect it to the list. Okay, we've connected it up. And now at the end, we want to move current along. We don't want to say current equals current next like we normally would. Otherwise, it's going to point to this node. We want it to point to the original node in the list that we want to duplicate. We want it to move to here.
Is it next?
Yeah, so we can say current equals next, or current equals new node next. And we just keep doing that. And that will do that again and again and again. Let's just check it to see if it works. A, Z, C, D, D. A, Z, Z, C, C, D, 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 D. Okay? Does it work if there's nothing in the list? Yep. Does it work if there's one thing in the list? Yeah. You know, so I think with that kind of question, once you see the code, does this look like code that is familiar that you understand? Yep or no? Okay. When you see the question though, would you be able to come up with this solution? Okay, yep. So the key is, if you're not sure, draw a diagram and try and work it out with the diagram step by step, like I sort of just did, to work out what's connecting to what. Otherwise, it's really easy to get it mixed up a bit. All right. I won't do this now because we're not going to have time, but there's another, I can do this next lecture. There's another 2-dot linked list hurdle example. And I've got some 2-dot array hurdle examples. So one of them's the type where I don't think we've got time in 5 minutes. One of them's the type where we write a whole program. One of them's the type where we're looking at a 2-dimensional array. So we've got those that you can look at and try, or I can cover in the next lecture. I've also got a debugging string question that we can go through in the next lecture, or you can have a look at in advance. The other thing I wanted to do, which I've nearly done on a few things, is to go back to this email management system thing that we did a couple of lectures ago, where we've got more complicated structs. So this would be more along the lines of doing like a 3-dot question. This would be more along the lines of, say, a question 10 in the exam. So depending on how people feel, we can, if we've got time, we can do that in the next lecture. Depends if you want to stick to 2-dot things, if you want to throw in a few hard things, we'll see how we go. Let me know if there's anything you want to do or not do in the next lecture, because it's the final lecture. The other thing in the final lecture is, we'll have our final Kahoot. We'll have a Q&A with some of the tutors at the end. So in the last half hour, they're going to come up and talk about exam tips, what people might want to enrol in next term. Lots of people have questions about future enrolments. Some people have questions about internships, jobs, becoming a tutor, anything like that. Come and ask them in the last half hour of the last lecture on Thursday. Yep.
Do we need to be worried about unsigned and signed integer chars at all?
Do we need to worry about what?
Unsigned and signed integer chars and whatnot.
No. The question was, do we need to worry about unsigned chars and integers? That's for COMP1511.
Because you use LU, percent LU.
Yeah, sometimes if you're trying to print out a string length, the compiler complains. You don't usually have to print it out though, so usually it's okay. Yep. All right. That's it. Thanks for coming. Let me know if you've got any suggestions that you want to cover in the next lecture. If you've got problems with the assignment or anything, come and let me know.